hello and welcome to another video. This one was sent to me by Danniella. It looks like it was a fun question actually to do over my toast this morning. And these ones aren't easy. I don't think they're easy, or it's very easy to get lost in the algebra and end up in a sea of confusion, sort of drifting into the mathematical fog. But yeah, looking at this, I don't want to mess about with arctans in this question, so I'm going to take it straight onto the left hand side and make it tan y is sine x, yeah? And then implicit differentiation doesn't scare me, it's normally the easier way to do things. So I'm going to differentiate this implicitly. And so I'm going to differentiate tan y, I'm going to get sec squared y, but because I've differentiated a function of y, I'm going to attach a dy by dx on the end. I'm going to differentiate sine x, the hyperbolics are dead easy to differentiate, even easier than sine and cos, because there's no negatives involved, so that's handy. Now, I looked at this, and actually, while I was drinking my coffee and having my toast, initially I started differentiating again using product rule on this, but I then sort of like paused and thought, well, hang on a second, is it not going to be easier if I just use the fact that 1 plus tan squared y is sec squared y, because then I can write everything in terms of x, and so I won't have that situation where I need to attach dy by dx's because I've differentiated a function of y. So I kind of like reversed a little bit then and thought, well, hang on a second, as 1 plus tan squared y is sec squared y, this means that in this case 1 plus sine squared x, because tan y is sine x, is going to be sec squared y, yeah? And it just gives me a little like shortcut here to make things a lot simpler, yeah? So what I'm going to do is I'm going to replace this with 1 plus sine squared y, 1 plus sine squared x, sorry, that's the whole point, change the y's for x's, dy by dx equals cos x, and then I thought to myself, hang on, isn't 1 plus sine squared cos squared, because cos squared x minus sine squared x is identical to 1, yeah? And so 1 plus sine squared is cos squared. So I then wrote cos squared x dy by dx is cos x. I got slightly nervous dividing both sides by cos x, and then subsequently realised my nerves were not really totally uncalled for, because can cos x ever be 0? No, it can't, because it's a catenary, I think that's what they call it. It's like a hanging chain, if you like, and it goes through 1. And so cos x never takes value of 0. So you can easily divide by cos x, don't worry, don't sweat it. Okay, so I got this, and I thought that's much easier to deal with. I could have taken the cos x onto the other side, but I thought, no, I'll just do product rule and differentiate cos x, I get sine x, times it by the other side undifferentiated. Notice I don't have to worry about attaching dy by dx's now, because everything's functions of x. And then I differentiated this, that's going to give me with respect to x d2y by dx squared, and I times it by this undifferentiated, and then I differentiated 1 and it went to 0, yeah? And I thought I'll quickly rearrange this to make it d2y by dx squared cos x is minus sine x dx, dy by dx, sorry. And I basically differentiated again, because I thought, well, and always look where you're going here. In fact, I might even pull this question down, just so I can see it next to me, the answer, because you want to constantly have, sorry, that bit, let's highlight it, in your mind, thinking this is what I need to end up with, yeah? Oh, screwed over a bit too much there. I'm looking for that, yeah, that's what I'm trying to get. So I'm going to differentiate once again, so I've got d, the third derivative. I'm going to have to use product rule again on both sides. So d3y by dx cubed times it by the other side undifferentiated plus sine x d2y by dx squared equals, similar thing over here, you're going to differentiate, minus sine x and get minus cos x, times it by the other side undifferentiated, and then you're going to differentiate this, you're going to get d2y by dx squared, but you're going to times by that undifferentiated. And I thought, okay, and then I've sort of slightly realised that I'm going to have a little bit of an issue still, because have I got everything in terms of dy by dx? No. Yeah, so I need to get rid of my d2y by dx's. But look, that sits with that one nicely, because they're both exactly the same term. And so what I did was I rearranged it into this. d3y by dx cubed equals... Now, excuse me. I'm going to move this over here, and so that's going to become minus 2 sine x. But I'm going to divide by cos x as well. d2y by dx squared. And then this I'm going to divide by cos x, so I just get minus dy by dx. Whoa! It's not easy writing on these graphics. My graphics tablet, it's quite an old one, and it's not really necessarily that good. But yeah, okay, so let me just neaten some of this up so you can read it. Okay, so we've got this, yeah? And we're trying to get this. Well, what's the one fly in the ointment? Well, I've got a dy by dx there. The fact that it's negative is slightly concerning. I've got a d2y by dx squared here. I don't want that. So if I can write d2y by dx squared in terms of dy by dx, that would be good. And I can, because look at this equation up here. I'm just going to put note that from star, d2y by dx squared is actually equal to minus sine x over cos x, which is of course tan x, or minus tan x, times by dy by dx. So in other words, I can replace that so it's solely in terms of dy by dx. Now what's that going to give me? That's going to give me d3y by dx cubed equals, okay, let's take the dy by dx's out, because both terms now are going to have a dy by dx. That times that is going to give me that. And then I'm going to have minus 2 sine x cos x multiplied by minus sine x cos x, which is going to give me plus 2 tan squared x. I've done a couple of things in my head there. And then there would be a dy by dx on the end, but I'm going to factorise that out. Yeah? Hopefully that's okay. Now, I now need to somehow come up with a dy by dx cubed. Well, don't forget that dy by dx is 1 over cos x, which is of course sec x. Lovely. Okay, so is tan related to sec? Yeah, because note that 1 minus tan squared x is sec squared x, not 1 plus tan squared, because according to Osborne's rule there's an implied product of sine in there. There's a sine squared on the top, and therefore this changes to a minus according to Osborne's rule. And so I can now use this to say, well, 2 tan squared x is therefore going to be equal to, rearrange this in your head, you're going to see you get 2 minus 2 sec squared x. Now in our case, that's 2 minus, where was it? 2 minus 2 dy by dx all squared. And that pretty much gives you the answer. Yeah? Let's put it like this. 2 minus 2 dy by dx all squared. And so, finally, we can say d3y by dx cubed equals dy by dx times by, okay, we're going to have minus 1 plus 2 minus 2 dy by dx all squared. Yeah? And what does that give us? It gives us a positive one, which we wanted, minus 2 dy by dx squared. But if you multiply it out in the brackets, you'd have their answer, I believe, which is 2 dy by dx all cubed. And that completes the proof. Let's just check that's what they wanted. Yeah, perfect. So yeah, a little bit of a fiddle. These ones often are a little bit of a fiddle. They're not, you know, they're not one-liners. Definitely not. You can see that with the 7 marks. Really, they're definitely implying it's going to be difficult. I'll finish the question off, but I reckon it was probably part A which you were stuck on. Okay, because you know, and that's the thing with these questions. Yeah, show that questions. Remember, you can still do the rest of the question if you can't get the show that right. It doesn't rule you out of getting all the marks for the rest of the question. So if you get stuck on this bit, you go straight on to B and you start doing that, because these marks are not unavailable. They've told you the answer because they want you to get the rest of the marks in the question. Okay, d4y by dx to the 4, I can just directly differentiate this with respect to x, equals d2y by dx squared minus, okay, we're going to need chain rule on this bit, differentiate inside the function, you get d2y by dx squared, then differentiate stuff cubed, you're going to get 3 times the stuff squared, yeah? And that's how you differentiate that. So d4y by dx to the 4 is d2y by dx squared minus 6 d2y by dx squared multiplied by dy by dx squared. And then to find the fifth derivative, well, product rule here, d5y by dx to the 5. I really would prefer writing down y yiv. But let me just try and write that down neatly. Okay, that's going to be d3y by dx cubed minus 6 times, and I just leave the 6 out because it's just a constant, it doesn't affect anything. Okay, I'm going to differentiate this with respect to x. That's d3y by dx cubed times by this side undifferentiated plus. Now I'm going to differentiate this. This is quite difficult to differentiate because I'm going to use chain rule again. So I'm going to use 2 dy by dx, yeah, that's stuff squared differentiates to 2 times stuff, times by, now you've got to differentiate inside the function, you're going to get d2y by dx squared there, and then you need to multiply that by the other side undifferentiated, so multiplying it by d2y by dx squared. In other words, this one is going to become squared. Okay, and then that finally gives me d3y by dx cubed minus 6 d3y by dx cubed dy by dx all squared plus minus 12 dy by dx d2y by dx squared. Let me just check my notes and make sure I've got that last one right. Okay, minus 12 dy by dx squared minus 6 d3y by dx squared dy by dx squared. Good. I just did it in a different order. Okay, so right at the very end, we just got to use the Maclaurins. Now, shall I just quickly get the Maclaurins from my other screen? It's in the formula book, obviously, but it's always worth reminding ourselves how we use it. It's not a mega complicated formula, Maclaurins, to use. It just involves plugging in x is 0 into a series of derivatives and then using something which looks very similar to binomial expansions. I'm sure you'll agree. Let me just show you the formula now. Handy to have a look at it. Okay, that's what we need. So I'm just going to use that. So obviously I need to plug in x is 0 into y, and if x is 0, now this is where we need to go back over all our working. Right, if x is 0, then y is 0, because tan of 0 equals sine of 0, because they're both 0. Or if you prefer, go right way back to the original, y equals arctan of sine of 0 is 0, arctan of 0 is 0. Yeah, so y equals 0. Yeah, I'm going to put it like this: when x equals 0, y equals 0, y dash equals, sure you can see why I'm doing that, because I'm so messy. Right, dy by dx or y dash, cosh of 0 is 1, 1 divided by 1 is 1. Y double dash, what's that going to be? Well, d2y by dx squared was, what did we have that? We had that something because we subbed it in, didn't we? Oh look, here it is. This is why it's so handy if you have neat working, which I don't really. So I'm going to be using, sorry, not that, missed. I'm going to be using this, yeah. So, okay, we already know when x is 0, dy by dx is 1, but this is going to give us minus sine of 0 over 1, and 0 times anything is 0, so that's going to be 0. Y triple dash, what's that going to be? Well, we can use this thing here, and we can see it's going to be 1 minus 2 times 1 cubed. That's minus 1. Y4, the fourth derivative, that's up here. And you can see you've just got second derivatives occurring in both terms, and they're 0. So 0 minus 6 times 0, you get 0. And finally, Y5, well, that's going to be, if we look at this carefully, we're plugging in third derivatives here, here, and here. Dy by dx is 1. here and here. Oh, and d2y by dx squared, sorry, that is 0. And so what have we got? We've got minus 1 here. This is a worse one to do. It's where you could definitely make a mistake. Minus 6 times minus 1, well, that becomes plus 6 times 1. And then that last term just disappears. And so we get 5 here. Okay, we can now write down the answer. That f of x is going to be equal to 0 for the first term. Then we're going to get plus x for the second term. Minus x cubed over 3 factorial for the next term, and then for the term with to the power of 5 in it, I'm going to have plus 5 x to the 5 over 5 factorial, and that is x minus x cubed over 6 plus x to the 5 over 24, and I think we're done. Yeah. So that's how I would have done that question, Danniella. It was good. It was good having a go at that over my toast this morning. So keep sending me interesting questions to do while I eat my toast. Okay, thanks everyone. Good luck in the next exam. I hope you absolutely smash it. I hope it goes really, really, really well. Remember, if the questions are difficult as well, that can actually be to your advantage sometimes. It depends. As long as you get it right, I guess it's to your advantage, isn't it? But yeah, anyway, keep up the hard work, and you can do it. You can do it. Bye-bye.